Okay, so let's take a look at the homework from last night on page 417. All right, so the first one we're going to look at is number 2. Okay, so number 2 is the tangent of 15. Now, I can do this one two ways. I can either look up the formula that involves tangents, or if you don't know that one, what could you do if you couldn't look up that formula? Instead of doing tangent, you can do a fraction of what?
Sine of 15 over cosine 15.
I could do sine 15 over cosine 15. But since I can look up tangent right now, it's going to be faster to do it that way. So we're either going to have to write 15 as a sum or as a difference. You could do it either way. What's one way I can get 15, either as a sum or difference? And I've got to use numbers that are multiples of 30 and 45. Yeah.
45 minus 30.
45 minus 30. Okay, so we're going to treat this problem as a tangent difference. Okay, I'm not sure what the tangent difference identity is off the top of my head, so I need to look it up. So tangent of a difference. All right, so it's tangent of the first minus tangent of the second. Let's start with that. So tangent of the first minus tangent of the second over, let's go back. All right, and it's over 1 plus the product of the tangents, first and second. So 1 plus the product of the tangents. All right, so 1 plus tangent 45, tangent 30. Tangent 45, tan 30. All right, when we deal with angles that are multiples of 45, what square root comes up a lot? Whenever we're dealing with the 45. Square root of 2 comes up a lot. Sometimes it's just square root of 2, sometimes it's root 2 over 2. Those seem to come up. And what square root comes up when you deal with 30s and 60s? Yeah.
Square root of 3.
Square root of 3. Sometimes it's square root of 3 over 2. Sometimes it's square root of 3 over 3. But those are the square roots that come up. So let's go through and simplify all those trig expressions first. So tangent of 45. Again, if you don't know it, that's okay. You can type it in. And as long as we recognize a decimal, if we get one. So tangent of 45, that just comes out to a nice number. 1. Minus the tangent of 30. All right, so that one as a square root is the square root of 3 over 3. Okay, so that's 0.577. So there's only like maybe 4 of them you have to know. There's involving square root of 3 and square root of 2. I'm not sure if that one came up yesterday, but that's one you should know. 0.577, roughly, is square root of 3 over 3.
So if you didn't know, just know that, how do you find it out? What's square root of 3?
The only way you could find it is you'd have to do unit circle trig. So if you didn't know it and you wanted to find the tangent of 30 by hand, it's probably going to take a couple minutes to do it. I mean, I can do it pretty quick, but you'd draw your circle, you'd mark 30 degrees, you'd make a triangle, and in a 30, 60, 90 triangle, you would have to know that the short side is a half, and the long side is root 3 over 2, and the hypotenuse is 1. All right, so now if you want 30 degrees, tangent of 30 degrees is opposite over adjacent. Opposite over adjacent. And now when you divide two fractions out that have the same denominator, the denominator cancels, or some people think of it as multiplying by the reciprocal. That's the same thing. And you get 1 over the square root of 3. But what's wrong with leaving an answer like that? Yeah? Can't have a square root in the bottom, so if you fix it, after all that work, you finally end up with the number that I just recognized on the calculator. So if you don't know it, you can figure it out, but if you have to go through unit circle trig, like 1, 2, 3, 4 times, it's gonna take forever. So some of these you probably want to just kind of recognize. There's about 4 of them. Root 3 over 2, root 3 over 3, root 2 over 2. I think that's it. Those are probably the 3. And I guess just the square root of 2 and just the square root of 3 by themselves, not as a fraction. All right, so let's continue on. So there's the top. Now in the bottom we have 1 plus, I just did the tangent of 45 up at the top. That's 1. Times, and I just did the tangent of 30 at the top. That's root 3 over 3. So that's basically our answer. It's a pretty messy way to write it, but that's the answer. So let's see if we can just clean it up a little bit. So as far as the trig, that's done. We're just going to try to do a little arithmetic to make this look nicer. So maybe we won't have fractions over fractions. So we have 1 minus the square root of 3 over 3 over 1 plus the square root of 3 over 3. What could I multiply everything by, all 4 terms, so that I wouldn't have any fractions anymore? As long as you multiply everything by this number, it's okay. Yeah?
Square root of 3 over 3? Or
even simpler. To just get rid of all the fractions, yeah?
3.
Just multiply everything by 3. And just triple everything. Triple everything in the top, triple everything in the bottom, and that's going to clean it up a lot. We're going to have 1 times 3 minus the square root of 3. Those 3's cancel. In the bottom, 1 times 3 again, and then when you multiply here, those 3's cancel. Square root of 3. Okay, so that's a lot better. Right, so you could leave it like that, and that's okay. I mean, technically there's a square root in the bottom, but if you got that far, that's pretty good. If you really wanted to know what to do from there, you would multiply top and bottom by the conjugate, and that would get rid of all the roots in the bottom. But I'm not worried about that for this one. Okay. So that's the tangent of 15 as far as I want to take it in this one. 3 minus the square root of 3 over 3 plus the square root of 3. All right. So any other questions on number 2? Okay, let's take a look at number 9. All right, so number 9 says, express each of the following in terms of sine, cosine, tangent, or cotangent. Sine of x plus 9. So what they don't want is inside the parentheses to have a sum. They want us to get rid of that. So this is the sine of a sum. So we have an identity for that. Let's go back and look at it. Double angle, sine sum formula. Okay, so I didn't save it. But can somebody remind me what the formula for the sine of a sum is? Rob?
So it would be cosine, or wait, or sine of the, I don't remember the name of that symbol.
Alpha?
Yeah, alpha times cosine of beta.
I think you're thinking of a different formula. I think you're thinking of a cosine sum or difference. No?
No, I got sine
Trying to remember.
alpha times cosine beta.
Oh, you're right,
plus
yeah.
Sine
I'm sorry.
cosine beta.
Yeah, you're right. It's the sine, cosine. I always mix them up. Sine, cosine, cosine, sine. When you have them both the same, that's when it's cosine. I was thinking that one. So it's cosine, cosine, sine, sine. That's a different one. All right. So you had sine, cosine, cosine, sine.
Yeah.
Okay. So sine, cosine, cosine, sine. All right, let's go back to the problem. All right. So sine, cosine, cosine, sine. And the one thing hopefully I do remember is that if it's a plus here, it's also a plus there. That part seem right? Okay. So we've got x 90, x 90. We're not going to be able to do anything with the sine x and cosine x, but we are going to be able to do something with the cosine 90 and sine 90. So this is sine x times cosine of 90. So that's a quarter of the way through the cosine cycle. So I'm just kind of picturing the graph. And where am I a quarter of the way through the cycle?
0.
Yep, I'm at 0. So 0 plus cosine x. And now the sine of 90. Now I'm picturing the graph of sine. Starts at the origin, quarter of the way through the cycle.
1.
Yep, I'm up at 1. So that part's gone. And the final answer is just the cosine of x. And that's how you do number 9. Any questions on that one? All right, what else we got? So we got 2, 9. Let's take a look at number 10. Probably similar. Yeah. Tangent of 180 plus x. Now that one might be a little harder. We might need the calculator because the graph of tangent, you might not remember that one as well as sine and cosine. All right, so that's the tangent sum identity. We just did the tangent difference. So when we had tangent of a difference, it's going to be the same formula, except these signs are going to flip. That's the only thing that's different. So it's tangent, tangent in the top. So tangent, and then tangent, except I want to use the opposite sign. So when we did a difference, I used a difference. We're doing a plus, I'm going to use a plus in the top. Over 1, that part stays the same. When we did a difference, we had a plus in the bottom. Now we're doing a sum, we're going to put a minus in the bottom. Minus. And then I think it's just the product of the two tangents. Tangent, tangent. Yep. All right, so tangent and tangent. So try to simplify the tangent 180s, and hopefully we get a nice answer. Let's see what we get. So tangent of 180 is 0. All right. So that means in the top, all you're going to be left with is tangent. And in the bottom, all of that is going to cancel out because tangent 0 times tangent is 0. So all you're left with is 1, and tangent divided by 1 is really just tangent. Okay, any questions on that one? So what that's basically proving is that if you take tangent and you phase shift it 180 degrees, it's exactly the same as the original. It would line up perfect again. That's because the period of tangent is 180 degrees. So that's what we just basically proved there. Let's look at 40. Let's look at 41. 41 says, solve each equation for x, find exact answers when possible, and then check your answer on the calculator. Sine x squared minus 1 equals 0. Sine x squared minus 1 equals 0. Okay. So the goal is to get x by itself. Right? First thing you have to do is at least get that by itself. What could I do on both sides to get what's in the box by itself? What?
Add 1.
Yeah, add 1. So let's start with that. And now, you can kind of think of, if it helps, you can think of it this way. It's the same thing. In fact, the second way is how you'd have to type it in on a calculator. So I can't touch anything that's in the parentheses till I get rid of those parentheses. And to get rid of them, what would I have to do on both sides? Yeah, we're going to take the square root of both sides. So square root. Those cancel. What's the square root of 1? Madison?
1. What?
It says, what's the square root of 1?
Isn't it 1?
Partially. Yep.
1 and
1 and negative 1. All right, so sine of x equals 1. If you want to write it as 2 equations, you could put it like this. Sine x equals 1. Sine x equals negative 1. Now I'm ready to get rid of the sine function and get x by itself. So what gets rid of the sine function? We can only cancel that out with another function. Yeah?
is it, I forget what it is, but it's like a -1.
Yep, it's like that. That's how you write it. Do you want to remember the name?
Like sine -1 or like negative sine out of
Yep, so we got that with Nathan, but we got to just go one step further and get the name of it. Yeah?
inverse sine.
Yes, inverse sine. So take the inverse sine of what's on the left. That gets rid of sine. So there's one answer. And take the inverse sine of what's on the right. Okay. Now remember, when you do inverse sine, you can get 2 answers. I have a feeling that probably going to get some overlap here. Bless you. Okay, let's take the inverse sine of 1. Okay, and we're going to get 90 degrees. Okay, so we get that one. And let's do this one. Inverse sine of -1. You hit -1 3/4 of the way through the cycle. What's the angle 3/4 of the way through? If you don't know, you can just do inverse sine -1.
270.
It's 270. Yep. And those are the only places you hit 1 and -1 within one cycle. Just think of your graph. It hits 1 only one time. It hits -1 only one time. And I think that's it. Now, they did specifically say the interval from 0 to 2 pi. So they probably wanted radians for answers. So you should have had pi over 2 and 3 pi over 2. But if you got to 90 and 270, you did it right. You got the whole thing. You just change it to radians. Okay. Any other questions on that one? If you got to the step where you took the square root, I'm guessing a lot of people, when they took the square root of 1, forgot to write both answers. If you got to that step. All right, so that was 41. Let's take a look at 31A. All right, so 31A. It says, let sine of x equal 2/3. So they're giving me I guess they're just giving me a piece of information. And they're telling me x is between pi over 2 and pi. In degrees, they're just saying x is between 90 and 180. All right? It says find the value of each expression. The cosine of x. All right. This one might. Well, there's a couple ways we could do it. We could do inverse trig and try to solve for x, but the question isn't really to solve for x. The question is to find the cosine of x. So you never need to know x. You need the cosine of it. So let's draw this out as a picture. We know that the sine of x is 2/3. And we know that x is between pi over 2 and pi. So what quadrant am I going to be in when I draw my picture?
The first.
Well, first quadrant, your angles would be between 0 and pi over 2. So your angles are between pi over 2 and pi. Yep.
Second.
Second. So that's a second, that's telling you to draw your picture in the second quadrant. The statement sine x equals 2/3 is telling you what to label your triangle. All right, so let's draw our triangle in the second quadrant. It's not to scale. So your reference angle, your reference angle is always tucked in between the hypotenuse and the x-axis. What's the definition of sine? If you think of it as something over something, I'm looking for two words. Yeah?
Opposite over hypotenuse.
Opposite over hypotenuse. Opposite over hypotenuse. Now, they're asking for the cosine. Gabe, what's cosine?
Adjacent over hypotenuse.
Yep. Adjacent, that's a problem. I don't know it. Over hypotenuse. So that part I know. So it's something over 3. But I need to find the adjacent. How can I get the adjacent if I have the other two sides? Chris? Yeah. We can temporarily just call it x. And then just solve using the Pythagorean theorem. So x squared plus 2 squared equals 3 squared. So we're going to get x squared equals 5, because 3 squared is 9, 2 squared is 4, and 9 minus 4 gives me 5. So x is the square root of 5. Now I can answer the question. The cosine is adjacent over hypotenuse. But what do I want to be careful about with this square root of 5? If I put this is wrong. Mark that wrong. Yeah?
Is it negative?
It's negative. The reason it's negative is because you're in quadrant 2. You went left. Okay? If you're in quadrants 2, 3, or 4, something is always negative. Either x, y, or both. Okay? So x is negative. Now it's correct. So negative square root 5 over 3. Okay, and that was 31A. Any other questions on 31A? All right, and what else do we have? 45. Okay, so 45 says, use example 2A to verify that, okay, it's a verify. So it's kind of like one we did yesterday, and there's one on the test similar. So it's sine of pi over 2 minus alpha. And since it's a verify, they're telling you what it's supposed to be. So when we're done, that's the goal. Okay, when you do a verify, you always start with which side? Yep, always start with the more complicated side and try to simplify it to the other side. So, look at the left-hand side. There's a name for what we have there. What type of identity is on the left? Is it a Pythagorean? Is it like a reciprocal? What do we have on the left? So I'm thinking of this 2 words to describe it. And it's what we started out with yesterday. It's the first group of things we looked at. Yeah?
Sine difference?
Yep, it's a sine difference identity. So remember, you got your sine sum and difference, cosine sum and difference, tangent sum and difference. That's a sine difference. All right. So I know when you have the sine difference, you put a difference between them. And can someone remind me what the first 2 terms are? in the sign difference? Yeah.
Sine, cosine.
All right. So it's sine, cosine, cosine, sine. And now just fill in first, second, first, second. First, second, first, second. So if this was on the test, that's the first thing I'd look for. Did you take this and turn it into that? Okay, at least if you got that, you'd get some points. Now the next step is to simplify anything that's numeric. So sine pi over 2, cosine pi over 2. What's the sine of pi over 2? If you want to think of it in degrees, it's the sine of 90. So it's 1. Yep. So 1 times cosine minus, and now the cosine of pi over 2, or cosine of 90, is how much? Yep.
0.
Yep, 0. Usually one of them comes out to like a positive or negative 1, the other one comes out to 0. You can just cross out the one that came out to 0. That's gone. And hopefully when you do out what's left, you better get what they told you to get, or something's wrong. 1 times cosine is cosine, and that's exactly what I was supposed to get. So that's number 45. Okay. Any questions on that one? All right, so those are all the ones we asked for up front. Does anyone else have any other questions that, after kind of going through some, maybe something else popped up? Yep.
For like 34, when we like got like the pi over 2, is it okay if we like made that into decimal?
For 34?
You did 41.
Oh, 41. So 41, if you made that into a decimal, so you put 1.41 and 4.71.
Yeah. Because like I just did it on the calculator.
Since the direction said find exact answers, then you'd have to leave it like that. Yeah. So if you do it on the calculator, it's going to give you a decimal. Right? So what I usually do is, I wouldn't recognize this as pi over 2 if I saw the decimal probably. So I always do it in degrees first. And then if I need it in radians, I change it by hand. All right? So like if I got an answer like, let's say you had something like this. 5 times this divided by 12. Right? If I saw that decimal, you just said to me, what is that as a fraction? 1.30899969. I would have no idea how you got that. Right? But if I had something like, let's just write this out. So let's say you wrote the answer differently, 75 degrees. And then you change it by hand. 75 times pi divided by 180. That's how you convert from degrees to radians by hand. And then reduce it. Okay. So let's see. 15 goes into 75 5 times. And 15 goes into 180 12 times. So when I reduce that, I get 5 pi over 12. Okay. Now, let's type that in as a decimal. 5 pi over 12. That's the number that I had when I started, that 1.3089969. But I would never be able to get that just by looking at it. Only way I know how to do it, get your answer in degrees first, and then change to radians by hand. Okay, so you have to do it that way if they say exact answer. Okay, any other questions from 417? Anything else? Okay.